In this video, we're going to talk about entropy, enthalpy, and spontaneity. Spontaneous reactions occur if they're given the necessary activation energy. They will proceed without any outside assistance. And these reactions can either be exothermic or endothermic under different conditions. And to determine whether a reaction is spontaneous, we have to look at what is known as their entropy. Entropy symbol is S, and it's a measure of disorder or randomness. So delta S is equal to the entropy of the products minus the entropy of the reactants. When delta S is greater than 0, the reaction is more likely to be spontaneous. So let's talk about entropy in terms of a larger scale. So entropy in the universe. The second law of thermodynamics states that the total entropy in the universe tends to increase, which means that the energy is going from a concentrated form to a dispersed form. And in that dispersed form, energy is less able to do work. So let's use burning a piece of coal as an example. So coal is a concentrated form of energy, and when you burn it, the energy gets released as heat, which then disperses into the surroundings. And then in that dispersed form, that energy is less able to do work. So the natural rule of energy is to disperse and become less useful over time. An example in biology of an increase in entropy would be cellular respiration. So when you take glucose and you convert it into a usable form, that is a combustion reaction, aerobic respiration. But in cellular respiration, we are converting that energy into a usable form, and we're storing it into ATP instead of releasing it all as heat. So how do we know if a reaction is going to be spontaneous? So if the reaction is exothermic with an increase of entropy, then the reaction is going to be spontaneous at all temperatures. If a reaction is endothermic, so delta H is greater than 0, and there's a decrease in entropy, then they're not spontaneous at any temperature. But if the reaction is exothermic with a decrease in entropy or endothermic with an increase in entropy, it may or may not be spontaneous. It will all depend on the temperature. So what reactions normally cause an increase in entropy? So if we increase the volume of a gaseous system, then the entropy will increase. If the temperature of a system increases, the entropy will increase. And finally, if the state is going from a solid to a liquid or gas, or from a liquid to gas, the entropy will increase. So in chemical reactions, entropy will increase when you have fewer moles of reactants working to form a greater number of moles of products. So in this example, we have 2 moles of ammonia making 1 mole of nitrogen and 3 moles of hydrogen. So that would be an example of an increase in entropy. Another example of when entropy increases would be glucose breaking down to form carbon dioxide, and it's interacting with oxygen in that process. And thirdly, when we have solid reactants becoming liquid or gaseous products, or liquid reactants becoming gaseous ones. So we have liquid water breaking down into hydrogen and oxygen. So how do we represent entropy changes? So an increase of entropy has a positive value. So in this example, we're producing this, so we have a positive value, and a decrease of entropy has a negative value. So this reaction has a negative value, so entropy is decreasing because we are using more moles of reactant to make fewer moles of product. So that would be a decrease in entropy, so it's negative. So let's practice with some of these. So in these examples, we're being asked to determine the sign of the entropy change for the following. So the first one, we have bromine in liquid form converting to bromine in gaseous form. So it's going from a liquid to a gas, so that would be a positive entropy. The next one, iodine, solid going to iodine gas, also positive. The third one, we have a larger molecule breaking down into smaller ones, so that would be positive. The next one, we have 3 moles of reactant making 1 mole of product. It's going from aqueous form to solid form as well, so that would be a decrease in entropy. The next one, we have propane breaking down into carbon dioxide, so that's a combustion reaction. That would be an increase in entropy. And then finally, 2 molecules merging together to form a molecule, so that would be a decrease in entropy. So now let's check our work and see if we were correct. Yep, we were. So increase, 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 decrease, increase, decrease.